So we're focusing on developing advanced electronic and power electronics, information technology, communication, and software technology to make the electric system almost completely inspection-free, so therefore we can commission the system within an hour.
Today, solar systems are more expensive than we'd like to see. So plug and play is one way to reduce the cost of a solar system. So plug and play is kind of as it sounds, all the various parts are plugged together and there's no additional setup or really design or thinking that has to go into it. You just plug the components together and the system works.
Currently, the average installed cost in the United States for residential solar is $4.93 a watt. Nearly 60% of this number comes from what the industry refers to as soft costs. These soft costs consist of installation labor, permitting, inspection and interconnection, customer acquisition, financing costs, and installer margin. The teams at the Freedom Center and the North Carolina Clean Energy Technology Center have worked to design a plug-and-play system that addresses these factors and helps to reduce the overall cost, making solar more affordable and user-friendly for the average consumer. The system begins with modules that use a 3-prong plug for connection. These plugs include a third wire for equipment grounding, which speeds up installation and ensures the system is always safely grounded. These connectors plug directly into microstring inverters, which are mounted next to the panels on the roof. These inverters house all of the power electronics necessary to operate the system. From there, the microstring inverter plugs directly into a unit called the PV Utility Interface. This device would be owned by the utility and allow them to wirelessly see the output of the system to better manage the grid. The PUI also communicates with the microstring inverters and modules to ensure proper installation and operation. Even further, the PUI completes an auto inspection of all the components throughout each day for the entire life of the system.
The idea is that customers can go to a big box retail store, buy a plug-and-play PV system, go up on the roof, install the system, and plug it in the PUI, or the PV Utility Interface. And the goal is to produce electricity and feed it to the grid, or use it within minutes of plugging it in the PUI.
So we're looking at National Electric Code, other electricity standards, or other standards as they apply to photovoltaic systems, and saying, how does plug and play fit into this standard or code? How could we possibly recommend changing the standard or code so that the final system could be installed without requiring a traditional electrical permit or electrical inspection?
A lot of the features that a plug-and-play system can do in the future is very beneficial to utilities. For example, being able to see the production of a PV system at an instant. If you have a device that can send you signals every 15 seconds or every minute of how much the PV systems in your grid is producing, then you're able to better manage your grid.
So now when they come to install a bidirectional meter with plug and play, they would also install the PUI. So very little extra time involved for them. They install that PUI, and our idea is they would provide approval at that time as well for interconnecting your solar system.
Can communicate using wireless. So in the future, essentially you could control what your PV system is doing from your computer. It's basically the world's first fully automated PV system.